college, I joined Adobe Systems, where I've been working ever since 2020, since my joining. So the product I'm working on is Acrobat.js, which I have created from scratch using all the bleeding and modern web technology that we are going to talk about today. So if you want to read more about Acrobat.js, it's basically a web-based PDF viewer. I've written a blog in my company's technical section on Medium. So if you want to read more about Acrobat.js, you can go to the blog link here. I've also detailed some of my social media handles if you want to contact me. Okay. So another thing that I want to do before I start is I want to set the expectations from this talk so that we are all on the same page and we can take the most value out of this talk. So this talk is going to be about is going to introduce you to what modern content development looks like compared to what it was like 7 or 10 years ago. And I'm going to also introduce you to numerous capabilities that are being added to the modern web and see how it is revolutionizing how you develop with apps for the user. I'm also going to talk about how a modern front-end developer is not just someone who develops a website. It is a front-end developer can do much more than that, and we're going to see how that's possible. But let's also talk about what this talk is not going to be about. So it's not going to be a tutorial on any of the mentioned on any of the technologies that I will be mentioning in this session. So basically, it's just going to be an introduction and some details about the evolution of modern front-end development. But it's not going to be a deep dive or tutorial into any of this. And let's also talk about some of the prerequisites. So if you want to make the most value out of this talk, so it's not necessary, but if you want to make the most value, it would be preferable if you have some, if you're aware with some of the basic web development technology, and it's even better if you have even worked and developed some websites in the past. Okay, so let's look at the outline for today's session. So I'm going to start with the history and evolution. So what front-end development look like about 7 or 10 years from now, and how it has rapidly evolved into something that is much more revolutionary. And I'm going to talk about some of the new concepts and ideas that have developed over time in the modern content area. And then finally, we are going to talk about two new technologies that are now available with modern content developers to develop engaging experiences for the user. Okay, so let's start with the history and evolution. So the good old days of that stuff. So this was time when I was in the second or third year of my college, and hopefully, as most of you, I was always excited about 𝗬𝗏𝗏 being around the corner, and especially Cyberplus being a computer science major. But one of the favorite events for me in Cyberplus was that stuff. So, but during that time, what we did during the web development was that we would write some server-side code in PHP or maybe Python, and that the responsibility of that server-side code would be to get the data from the database and basically apply some business logic, process the database data, and send the process HTML back to the web browser for display. It will also include some CSS with that HTML to make it look good. Now, if we think about from the perspective of a front-end developer, obviously front-end developer won't be working on PHP, but the only control the front-end developer would have would be some little control over the HTML that will be sent from the server. And most of the work that front-end developer did was around writing the CSS, making the designs come to life and things like this. Other things that front-end developers did was using JavaScript to provide some interactivity to the content. And a major usage of JavaScript in that was performance validation, where you would create an input field, a form, for example, an email field, and you would want to validate that the content that the user has typed in that field is actually a valid email, then show an appropriate error message to the user. Another way you could use JavaScript in that time was for dynamically updating some part of the content of the website without actually reloading the whole page. And we used to use something called Ajax in that time to do that. But still, we mostly used to create multi-page websites where you want to really update the content, you move to different page actually. But in some places, you will here and there sprinkle Ajax. And for doing all this JavaScript form validation and interactivity, you would use a library, a very common library during that time, and even today, which is JQuery. So JQuery allowed you to do easy DOM manipulation, and you also had UI, which was sort of an add-on on jQuery, and it allowed you to use a lot of cool widgets like You could make fancy form village, form control, buttons, modal dialog, etc. But the reality was that if the web app was complex enough, and a lot of people were working on that on the web app, things could still get messy and the code would become difficult to work with. And moreover, like you would do all these things, like fancy things with CSS and JavaScript, but the reality was that if you wanted to do more things like video, audio, games, or animation, you would have to move to Adobe Flash, which was not really a front-end technology per se, and it had its own issues as well. Another problem that people faced during that time was managing of dependencies. So during that time, it was not very common to see. So you would go to the documentation of JQuery UI and it would be written that you have to manually make sure that you include JQuery before JQuery UI or JQuery UI platform. It was all manual during that time. And people couldn't even think of writing their JavaScript code in a modular way in different files, because then you would have to make sure that if A depends on B, you have to include B before A. If multiple people were working on code, it was hard to. So the result was that you would just write a large change movie of 2,000 lines, and it would ultimately get difficult to get. So then, during the period of 2009 to 2013, was the time when humble beginnings of the modern front-end development started. So front-end development was starting to get more complex. There were more things that people were requiring from front-end website, from the front-end of a website. And that's why there were a lot of problems that we were facing as a movement. And when people face problems, there are innovations that keep up when they try to solve these problems. So one of those innovations, first innovation, was the introduction of JavaScript framework known as ML.Js, which was introduced in 2010. And this was one of the first frameworks that introduced a new way to structure your application, a front-end application in the form of model, view, and control. So basically, the model would take care of the data of your application, the view would take care of the UI of your application, and the controller would take care of managing the data and the UI. After 2 years, the Angular was introduced by Google, which introduced a new concept of tool binding, where the model and view can update each other instantly. So this was sort of a revolutionary idea during that time. Apart from Angular, there were other frameworks that were also being worked upon, like Node.Js, Apart from just JavaScript framework, there was also work going around overall front-end framework like Bootstrap, which basically allowed you to, do responsive web design. So before Bootstrap, you would commonly find two websites being developed for one product. For example, you would find 𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏 basically for desktop website, you should develop it separately, and a mobile website, you should develop separately to make it optimized for the mobile. But Bootstrap introduced the concept of responsive design where you can use the same site code. And also has some cool, fancy looking widgets like for buttons, modals, and whatnot. Okay. But still, in this, all this innovation, during all this innovation, JQuery was okay. So, I have some Google Trends data here. So, if you see the graph on the left, you can see that Bootstrap, which was not really a JavaScript framework, it was more of a CSS framework, really took off because people were fed up of managing a lot of CSS things. Oh, is my voice not clear? Is my voice clear now?
Yep, your voice is clear now.
Okay. Yeah, so as I was saying, so Bootstrap really took off because people were facing problems with doing CSS. But JavaScript frameworks like Backbone, Angular, they were a little slow to take off. And the reason for that was that SPEVAS was still not complex enough. And people didn't really want to invest in learning new frameworks for their websites. Now, if I add jQuery into the mix, as you can see in the graph on the right, you can see how all of these just dwarf in front of jQuery. So people were still working with jQuery, and these frameworks didn't really take off during that time. Now, even during this time, innovations were not just happening in the JavaScript and the framework world. The innovations were also happening in the world of tooling and other areas that are important for development. For example, Require.Js were introduced in 2012, which removed that problem of manually managing dependencies between EMP. It provided a way for you to write code in a modular form, and it would automatically manage the dependencies for you, and you won't have to worry about those. Then there were also introduction of CSS compilers like SASS and less, which allowed you to write more modular and maintainable code without having basically these tools taking care of managing and creating a final CSS for you to make things actually work. Then there were also innovations done in the area of tooling, basically build tools. So Grunt and Gulp, which were introduced in 2012 and 2013, were the first task runners or build tools for the web, which allowed you to automate mundane tasks like minification of the JavaScript, running tests, etc. Another big revolutionary development during this time was Node.Js. So Node.js allowed you to run JavaScript outside the web browser. So before this, JavaScript could only be run on the web browser. You could use it to just develop websites, provide some interactivity. But what Node.js did was revolutionary. It allowed you to run JavaScript not just inside a web browser. You could run JavaScript to build command line tools. You can run even JavaScript on the server side, or you could even build native apps using JavaScript. So this really changed, revolutionized how front-end developers work. So front-end developer who has expertise in JavaScript could even use his expertise to develop server-side code and become full-stack developer. This also paved way for something called a server-side rendering, where when you're sending HTML from the server using PHP code, you would ideally want to organize your code, JavaScript code HTML and JavaScript code in a much better way on the server side as well. So you could just introduce the possibility of running frameworks like Backbone.js on the server to manage the HTML part. Node.js also came with a package manager called as NPM, which basically allowed people to share different packages, libraries, and utilities with each other. And we'll come back to the importance of NPM a little later. Okay. So even though these innovations were going on, we saw how jQuery was still the king. So what was limiting front-end development? And the reason for this limitation was that the main pillars of front-end development, which was JS, CSS, and HTML, they itself had flaws. So JavaScript, which was the only language that you could do front-end development with, was designed by Brendan Eich in just 10 days. And 10 days is much less for designing a complete language. The flaws, because of this just 10 days, clearly showed in the language. And this image on the right, quite funnily, shows one of the flaws in the confusing equality comparison operator in JavaScript. Another reason was that the JavaScript language itself became stagnant. So there was no real improvement going on in the JavaScript world. So even if it had flaws, you could improve it over time, but it was mostly stagnant, no improvements were going on. So another problem was the CSS itself was badly implemented across browsers. So something that works in one web browser then just completely break in another browser. And apart from these, the major thing that was limiting front-end development was that front-end code, the JavaScript code, and the APIs available to the JavaScript code were not really capable. So if you want to do more fancy stuff like video, audio, or animation, you would have to go back to Flash, and Flash has its own security and stability problems. Right. So then came the period of 2013 to present, which I would say marks the starting of the modern front-end development. So what happened during this phase? So during this phase, we saw thousands of tools, frameworks, libraries. People came up with a lot of opinions, ideas, and front-end development jobs took off. So the graph, you can see the top graph here. You can see the number of questions asked on Stack Overflow every month. You can see there is a rise around this period of 2013 and 2014. Similarly, the Google Trends data shows that 2013, 2014, and 2015 was a period when JavaScript frameworks really took off. Similarly, single-page applications, which I talked about a little bit earlier, where you would just not reload the whole page and dynamically update the UI in place, those also took off based on the Google Trends data. So basically, front-end development was becoming more and more complex, and there were more needs that were arising that were needed from the front-end technologies. So what changed? During this 2013 to the present time, what changed? What limitations were changed that it is now what's called modern front-end development? So the reason for this change is that the period between 2013 to 2016 saw a lot of improvements in all the limiting areas that we talked 2 slides ago. So the standard bodies like W3C, which basically makes standards for HTML and CSS, and TC39, which makes standards for JavaScript language, made their process more open, formal, and community-based. And this really revolutionized the front-end development process. And the key bearers of this evolution were the introduction of HTML5, CSS3, ES6, and NPM. So let's talk about what these are. So HTML5 was introduced in 2014, and it was the latest standard that was introduced during that time. Now, There was few minor things that HTML5 did, like introduction of some new tags for semantic descriptiveness. It also introduced full built-in form widgets like email. So earlier you would do some scripting to validate emails on your website, but now it was possible to just write input type equal to email, and the browser will take care of the validation and showing of error message to the user. There were also better DOM APIs that you could work with. But the main thing that revolutionized development with respect to HTML5 was that HTML5 embraced the web world. So in the web world, JavaScript is king. So you have JavaScript being the only language that you can work with. HTML5 did an intelligent thing by embracing JavaScript and introducing a lot of capabilities to the web using JavaScript. Some of those capabilities are listed here. For example, web storage. So earlier, before HTML5, cookies was the only way you could store data on the browser. But now you had a lot of different APIs to store data. Then it was also possible to natively embed video and audio in HTML5 without using Flash. It was also possible to get the geolocation of a user. It was also possible to drag and drop content from within your website. And then there are two other major things that happened. So first one was, it was possible to draw graphics using scripting using the Canvas API. So you no longer would need to use and create images for everything. You could just create images on the fly using JavaScript. Then there was an introduction of web workers. So before web workers, it was quite infamous that JavaScript was single-threaded, right? And what that limited was the ability for you to do high computation tasks in JavaScript. So if you were to do the high computation task in JavaScript, it would block the UI and the user experience would be bad. But with web workers, it was now possible to run a JavaScript file in a separate thread, and you could do high computation tasks in that background separate thread, and the user would not be blocked. Okay. So another big standardization that happened during this time was CSS3. So CSS3 also revolutionized how you write CSS and do styling. It fixed a lot of issues. It introduced some properties like border radius and box shadow, which earlier people used to do by a lot of hacks like introducing images and whatnot. It also introduced things like animations using transitions and transforms. It also introduced the concept of web fonts. So if you wanted to use some fancy fonts on your website, which may not present on the system, on the user's machine, you could use that with the web fonts API. But before web fonts, for doing things like this, you would generally use images even for text. Then CSS3 also introduced built-in support for responsive design, which was earlier introduced by frameworks like Bootstrap. Now that was built in CSS3 itself using media queries, where you can target different screen sizes and screen types and write different CSS from the same code base. Okay, so enough talking about HTML5 and CSS3. Let's take a look at some of cool demos. Okay, so here is a first demo. So basically, this is a physics sort of demo. So using HTML, CSS, and pure JavaScript, and not using any Flash or any native technology, you could just build a physics simulation of a tearable cloth. So basically, if I move my mouse here, you can see that the cloth gets teared, and I can also, introduce a break here and do more fancy stuff with this. And this is, believe it or not, happening all with JavaScript, Canvas APIs, and CSS. So that's what this was cool. Another demo is you can even play games in JavaScript. So this is using Canvas API and some JavaScript cool things to build this game. And obviously I'm not good at this game, but yeah. Okay, another one is this SVG animated bird. So you could see these birds are getting animated, and you could use this to build cool banners for your website. Now earlier, before HTML5 and CSS3, you would generally use a GIF image or maybe Flash for doing these things. But now this, as you can see here, this is just pure HTML and CSS animations. And you can build this capability from within your web app. Okay, so coming back to the slides. So another big innovation that happened during this time was the introduction of ES6. So ES6 is a new standard specification for JavaScript. So basically, a specification, if you're not aware, is basically a document that describes what the language supports and what the different syntax and concepts are. So ES6 was the new standard specification that introduced a lot of improvement to JavaScript. The older standard before this was called as ES5, and that was introduced in 2009. So 6 years was the big period between which no real development happened in JavaScript, and then ES6 revolutionized all of this. So ES6 fixed a lot of issues with the earlier standards, a lot of pain points of developers was fixed. And it also introduced a lot of easy to use and better constructs like classes, promises, and it also introduced native JS modules. So now it was possible to write modular JavaScript code, and you would not have to use a tool or a framework for managing your dependencies. Those could easily be managed by the JavaScript engine itself. Another non-operational sort of operational thing that happened during this time was the TC39, which is the standardization committee for all these JavaScript standards. They enhance their own process. They make their process more community-based. They made it more open, and they also promised that they would actually not make the language go stagnant anymore. They would make new standards every year, and keep improving the language continuously. Now, this liberated the JS community to collaboratively improve the language continuously. The one problem that crept up during this time was that you introduced a lot of good things with ES6, and you were also working on ES7 and ESNEXT. But the thing was the browsers were slow to catch up. So you were introducing a lot of new constructs like classes and promises, but the browsers were a little slow to implement those features, those JavaScript features in their JavaScript engines. So there was a possibility that the development, the growth of JavaScript would still be stagnant, but that was prevented by something called as Babel. So Babel is a compiler for JavaScript. So earlier, before Babel, you would just write JavaScript and run it directly on the browser, but now you have a concept of compilers for JavaScript. Now, Babel allowed you to write your source code using modern constructs, using all the ES6 and even things that have not been standardized at all. So if you like something that is still in progress for standardization, you could use it in your code, and then Babel will take care of compiling that code into older constructs which all other browsers support. You wouldn't have to worry about browser compatibility, but your source code is written with new constructs and is much more easier to understand and maintain. Right. So let's see a quick demo on Babel as well. So as I said, ES6 introduced the concept of classes, which was not present in JavaScript before that. So here I have a rectangle class with the constructor. It has 2 members, height and width, and it has functions to get the area of that rectangle, and then it uses dash to print the area. Now, on the right is what Babel has generated out of this code. So before the word of classes, you would use functions to simulate classes. So it has generated a code similar using functions, which has the same functionality as the one shown on the left. So that's cool. So Babel takes care of this for you, and you can just maintain this code instead of maintaining this code, right? Okay. Moving on, another big development was NPM. Now, NPM was not new. It was introduced as part of Node.Js in 2009, 2010. But what new happened here was the founding of a company known as NPM Inc., which was founded in 2014. Now, what NPM Inc. did, it created an open public registry containing a lot of open source libraries for Node.js, front-end development, mobile apps, and other needs of the JS community. And the main keyword here is community. So now you had an open registry where you could write your code or utilities or your libraries or your frameworks. You could ship it, and other people can just easily start using those. So the open source and the community culture was greatly improved with NPM. So this revolutionized sharing and collaboration across the JS community. Okay. So with all these improvements that happened with HTML5, CSS3, which added a lot of new capabilities and improved the developer experience and made the standardization process community based, it's a revolution today because of all of that. So modern JavaScript ecosystem is highly community driven. People are free and open to share their opinions and beliefs and ideas and come up with their libraries, frameworks of their own. So this is why there is an explosion of libraries and frameworks. So if you go and search the internet for any common name you can think of, you may find a JS library or a framework with that name. So there are like libraries with the name of Muka, Kai, even Jest, or there's even a library with the name of Thanos. Okay, so the NPM registry, because of this highly community-driven world, has over 1.3 million packages today. Okay, so keeping up with the latest and greatest in modern web front-end development today is not for the weak of heart. But it's nothing to be scared of. It's all for good, and it actually makes you a much better developer. There are a myriad of options at every stage of the front-end development workflow today. You have choices for different build tools, for different builders, compilers, JS frameworks, libraries, APIs, technology, architecture, etc. Okay, so with this revolution, a lot of new concepts and ideas were introduced because now things became community-based. People came with their own concepts, ideas, opinions, beliefs. So I will just go through some of the core concepts and ideas with modern front-end development. So I'll start with module bundlers. So a module bundler is a tool that takes your modular JavaScript code, and based on analyzing of that code, it understands its dependencies, the dependencies of your JavaScript codes, and generates a final optimized bundle that can then run directly on your web browser. Now, some bundlers also take care of things outside your JS code. So if you think about a practical web app, it's not just about JavaScript, right? You have images, fonts, CSS, etc. So some bundlers, in fact, when you use these fonts or CSS or images in your code, they also make note of that and make sure that the final package that is there also contains the dependencies, these static image and font dependencies as well. So overall, this enables you to write much more modular code for as much complex applications you have without your head hurting. Some of the common examples of module bundlers today are Webpack, Parcel.js, and Rollup. Okay, so the next big concept here is the concept of transpilers. So transpilers are source-to-source compilers, which basically means that they take source code written in one language and they produce code with the equivalent functionality in another language or another version of the same language. So transpilers basically do what compilers do, but they take input as one source language and spit out another source language. Now, Babel, as we saw some time ago, is an example of a transpiler, which allows you to write code using new language features, and without worrying about browser compatibility, you could generate JavaScript code using older language features. Now, with the concept of transpilers, people also started building extensions of the JavaScript language. And the reason for that mostly was that now that JavaScript and front-end development was evolutionized, more and more people were, trying front-end development, and more and more people were getting into front-end development. And a lot of these people were coming from, languages like C, C++, Python, which had, some of these languages had, static types where, in C++, you would have to declare a variable as integer, and you would have to make sure that you always assign integers to it. And if you do not, it will throw compilation error. But some of you may know that this is not the case with JavaScript. You can assign any type of value to a variable. But people coming from these statically typed languages, they were facing problems when they were working with JavaScript. So Microsoft came up with TypeScript, which is an extension of JavaScript, which basically adds types to JavaScript and then finally transpiles to JavaScript to run in the browser. Then there was also introduction of something called as CoffeeScript, which improved the JavaScript syntax by taking inspiration from syntaxes in languages like Ruby, Python, Haskell, etc. Apart from these extensions, it was also possible to compile other languages to JavaScript like C, C++, Rust, right? And I'm going to talk more about this in a bit as well. And then Google also introduced Dart, which was its own language, which it used for cross-platform application development. And when a Dart application would compile to JavaScript, it would compile to the web, it would compile to the JavaScript using a transpiler. Okay, so the last concept that I'm going to talk about is the CSS and in JS. So before CSS in JS, how when you were writing modular code, and let's say you were writing a form, let's say a login form, your methodology would be to write some HTML and then to write some JavaScript on top of it. And then finally, to style that form, you would need some CSS. Now, for using that CSS, you would have to depend on some external style sheet. And if that external style sheet was not properly included, your code would not really work. So CSS in JS solves this problem by introducing a new styling pattern where your CSS code is composed within the JavaScript itself instead of being defined in external style sheets and external files. And when this JavaScript is passed, the actual style is generated and attached to the appropriate DOM elements. Now what this enabled was that your components, like for example, your login form was more self-independent. Basically, it did not depend on somebody else to make sure that this style sheet is included. It could encapsulate all the styling it needed with its business logic, and it can independently be used anywhere. Now, there are various CSS and JS libraries today, like style components and JSX. Okay, so these are the concepts that I wanted to talk about, which took by due to the modern front-end development. Now let's take a look at some of the new cool technologies that came into being with this modernization. So the first one is WebAssembly. So WebAssembly is a new low-level assembly-like language that the browser not supports. So before WebAssembly, JavaScript was kind of the only programming language that the browser natively supported. But now this new assembly-like language was also possible to be run on a web browser. Now, obviously, since this is low-level assembly-like, you would not go and write it by hand. So this was mostly meant to be a compilation target for languages like C, C++, Rust. So like you would take your GCC compiler, take your C++ code, convert it into machine code and run it natively. Similarly, you would take a tool like 𝗏scripten and you will start with your C++ code, take it through 𝗏scripten, transpile it and convert it into WebAssembly, and now that same code can be run on the browser as well. Now this WebAssembly basically what it does is that it allows you to reuse your existing native code on the web. So if you already have a desktop or a mobile application and you have a lot of code base, C, C++ or Rust code base written around it, you could just reuse that code instead of rewriting something else and bring that same app to the web as well. This is especially important with the movement of data to the cloud, where people are mostly working with web browsers. Now, prime examples of these is the Acrobat.js product that I work on currently, which basically uses the Adobe Reader code, which we already have for our native desktop and mobile applications. So we have reused the same code to build a PDF viewer for the web. Similarly, Google Earth, which was released only as a native app by Google, is now possible to run on the web by taking the same desktop code and compiling it to WebAssembly and running it on the web. So, in fact, let me just show you the demos of this. So I'll start with Acrobat.js. So here is a demo showcase for Acrobat.js where you can upload any file, start viewing it. Let me select the PDF format, PDF representation of the same PPT. So you can see this, you can just view this PDF file in the browser itself. You can use all the functionalities that you would expect in a PDF viewer. And believe it or not, this is just working completely client-side without using any zero server code at all. And it's basically reuses the same code that we use in our mobile and desktop applications. Another example here is Google Earth, where you can, go and search Eiffel Tower, and it will zoom in and work like the native desktop application that some of you may have used. You can see, you can just inspect around Google Earth and see things. Okay, so in fact, instead of seeing the apps that have been already developed using WebAssembly, I think it would be more fun if we develop one of our own. So here I have written test.cpp file, where basically I have written a function to calculate a Fibonacci number, and then I printed the 10th Fibonacci number. Now let's see how easy it is to run the same C++ code on the web browser. So like you would use GCC, you would use a new compiler which is provided by 𝗏scripten called EMCC. You would type the name of the file you want to compile, and you would give the name of the output file, which would be an HTML. So when I run this file, it compiles the C++, and if I do ls again, it generates the HTML, the JavaScript, and the WebAssembly file. So this basically HTML will use the JavaScript and WebAssembly to run the same C++ code on the browser. Okay, so let me just run a simple HTTP server here. Okay, so now the server is running. So I can just reload this. So I can just open this HTML, and I hope you all can see that it has printed the 10th Fibonacci number, and it is quite quick as well, right? So when you are taking your native code to the web, it's also quite important that it runs with the same performance as your native app would, and WebAssembly is actually quite fast with respect to that. Okay, so let's move on. Okay, so another development in this modern web world was the introduction of new APIs and capabilities, and which was started by HTML5 in the past. So because the 𝗙𝗲𝘃 standardization process became more open and community-based, even the browser vendors like Google Chrome and Firefox, they could work on technologies of their own, and they can finally take it to 𝗙𝗃 for standardization. And that's what Google's project 𝗏𝗏 is. So Google has a project called as 𝗏𝗏, which is basically about adding new capabilities via APIs to the web. And the final aim is to make the web apps as much capable as native apps. Like, look at the sum of the capabilities and APIs that are in works. So for example, the web speech API, which allows you to, generate speech from text or even recognition. So basically you can talk using your microphone, it would be able to generate text. And this is all happening without using any native app, just JavaScript code. Similarly, you have the Bluetooth API, the vibration API, which allows you to vibrate your phone using JavaScript. Then there's WebRTC, which allows you to do real-time audio-video conferencing between browsers. So we are working on WebEx. So some of you may be using it from the website. So you can imagine how that is working. So another one is WebVR and WebXR device API, which allows you from your web app to render stuff in an AR or VR device. Then there's the Contact Picker API, which allows you to access contacts present on your phone. And my favorite one is the Native File System API. So a long requested deficiency on the web was that a web app could not access the files present on the native file system of the user. So this Native File System API actually enables that. And let's take a look at it in action. So here I have Google Chrome open, and this is the text editor, which uses the Native File System APIs to allow you to edit files, text files on your local system. So I can open a text file, for example, myfile.txt. I can start editing it. For example, can I really edit it on the web? Wow. Then if I go to this file menu and press save, it will for the first time ask me if you really want to see this website to be able to access your native file. Now this is done for security reasons, but it only happens once in this session. So if I edit it again, then again save it, just get saved. And now if I go to my file system and open this file, you can see the same content is reflected here in the native file system as well. Okay. Moving on, the next important technology in modern frontend is the progressive web apps. Progressive web apps, combine the best of both worlds. So if you compare between web apps and native apps, you would find that web apps have some drawbacks and some advantages over native apps, and the same is true vice versa as well. So web apps, the web apps generally are much easier to share. They are much easier reach. So if you have, let's say for the text editor that I showed you, if I just copy paste the link and send it to someone of you, you can just easily start using it without doing an install. While if in a native app, you would have to first make sure that that app is available on some app store, and you would have to then install it. Other problems with native apps is that they are not cross-platform. So if you develop an app for Windows, the same code would not work for Mac OS. So you need to develop a different app for Mac OS. While with web apps, you just write single code base and it works cross-platform, cross-device. It does not matter, it works everywhere. You just need a web browser, right? But native apps have their own advantages. They are much more capable. They can read, write local files. They can work with USB, camera, Bluetooth, etc., etc. And more importantly, they can work offline as well. While with a web app, you generally need the server for doing fancy stuff, for doing like saving data to the database and things like those. And moreover, native apps, since they are installed on the operating system itself, they feel more like the part of the device. While for a web app, you would go and launch a different app, which is the web browser, and then that app would just be a tab inside that web browser, which does not feel native-ish, right? So PWAs basically, combine the capabilities and the reach of web apps, capabilities of native apps and the reach of web apps to create the best of both worlds. So the last slide where I showed you a lot of modern capabilities that are being added to the web, those basically take care of the capabilities part, while web apps already have this reach problem solved for them. Now, PWAs can be installed like a normal native app on your web on your machine, and they can even be used offline, right? So let's take a quick demo. Look at a quick demo of a progressive web app. So in fact, this text editor is a progressive web app. So if I go to this install, you can see this install app pop up, and if I press install, this application text editor is now installed on my machine. So if I just close this, I can search it like any other native app I would search in my Mac machine. So then I can start doing the same things by reading the file and doing the editing and other stuff. Okay. Moving on, another thing, like this is something that I sort of mentioned during the Node.js slide, was that with Node.js, it was now possible to create even native apps using web technologies. So now You could reuse your reuse the code that you wrote in your web app, and you can reuse that same code for creating mobile and desktop applications using the same your favorite frameworks and using HTML, CSS, and JavaScript. So there are different tools that enable you to do this. First one is React Native, which allows you to create Android and iOS apps using React code. Similarly, there's Native Script, which allows you to create mobile apps using Vue.js, Angular, or even using plain JavaScript. Then there's Electron, which allows you to create cross-platform desktop apps. So React Native and Native Script allow you to use web technologies to create mobile apps, and Electron allows you to create desktop apps for Linux, Mac OS, and Windows. And React XP sort of combines the features of all of these and basically allows you to share code across web, mobile, and Windows apps. Okay. So moving on. Yeah, another possibility today, another key thing that's happening today is that now it's possible to do machine learning on the front end. So with the introduction of WebAssembly and a lot of capabilities being added to the web, and moreover, the browser also have improved their performance over time, that it's now possible to do machine learning even on the front end. The first question that may pop up is that machine learning is mostly done on the server, where you would have a large user data set, you would train your models on that and then use it in your website. So why do machine learning on the front end? Now, there are few use cases where doing machine learning on the front end would make sense, and that's for example, if you want to detect faces in a live video, you cannot just send frame by frame data to the server and expect the server to reply back to you with the with the information as quick in a quick time, which would feel responsive for the user. You would only be able to do that on the front end itself. Similarly, if you want your machine learning application to work offline, you could not depend on the server, and front end machine learning on the front end would help you there, right? Similarly, there are cases of privacy where users don't want their data to be sent across to the suite to your servers, and then so basically you can just do machine learning without sending the data to the server. And then there are also operational costs with maintaining a server. So there are different libraries and tools available for doing machine learning on the front end. And the first one is ML.Js, which is a JavaScript library which gives you access to a lot of machine learning tools. For example, metrics, array manipulation, data engineering, and even it also provides you some commonly used machine learning models that are pre-built in the library. So you can feed the data to it and start building your models. And then there's this big one, TensorFlow.js. So if some of you have worked with machine learning, so you would be aware of Google's library TensorFlow, which allows you to build neural networks and train your neural network machine learning models. But the same TensorFlow library is also available thanks to WebAssembly as TensorFlow.js. So now you can develop your machine learning models in JavaScript and use machine learning directly in your web browser. Okay, so that's all from my side with regards to modern front-end technologies, how it has evolved, and what the new technologies are. So I would like to conclude with a few key takeaways for this session. So the first one is that a modern front-end developer can do much more today. It's not just about realizing the designs, not just about adding interactivity, it's much more than that. A modern front-end developer can write web apps which have capabilities close to native apps. A web app developer can create cross-platform native apps using the same web technologies that they use to create web apps. A web developer can even work on C, C++, and Rust code bases and port those code bases into WebAssembly and use them on the web. A modern front-end developer can apply on-device machine learning inside a web app. And finally, I would like to end with the note that web apps are the future in this cloud first world. Okay, thank you so much.